In this lesson, what I'm going to be showing you is how we can control function operations with objects in our scene, both for animation and control within the interface. To show you what I'm talking about, I'm going to create a procedural terrain, and we're going to take a look at how we can control the function within our procedural terrain that generates the altitude with objects in the scene. And we're going to be developing a meta node to control all these operations that we can use throughout any function in any area of view. So if we right mouse click and edit our procedural terrain, go to edit function, I'm going to delete the seed offset that was created, and I just want to show you what it is we're going to be looking at. I'm just going to create a noise node. So we have a simple fractal and a noise node. And if I open the output observer up at the top, right now we see the connection to the simple fractal. If I connect this to our value Perlin noise, now we can see a much more simple version of basically the same noise, but we don't have the roughness that we get from a fractal. So I'm going to create a blender or a combiner node between these two. I'm going to delete that first connection because we want the first input, or input 0, to be connected to the altitude of our fractal, and the second to be part of our noise. So we now have a blender and a ratio. When this blender ratio is set to 0, we see the fractal on the left because we are using the blend mode. If I change this up to 1, now we see the noise. So what we're going to be doing is creating a tool and learning how we can manipulate this slider dynamically with an object in the scene, which gives us the ability to animate this, which was previously not possible in previous versions of Vue. But with Vue 7, now we have all of these available graph functions and external dependencies to allow us to connect this sort of a blend by controlling objects in the scene. So I'm going to delete this procedural terrain right now. And the first thing I want to take a look at is if we go to File and Options, and under the Units and Coordinates tab, we have an internal unit. By default, this is set to 0.1 meters. And this is going to be an important control factor because it manipulates the way our vectors work in the scene. And to show you what I mean by that, basically, I'm just going to create a sphere right now. And if we go to the position, we can see that it is moved 3 meters on the z-axis, on the up and down axis. And I also have the default order set for our order of rotations, and also which axis is up. So basically, if we were to control this vector and position, or even take a look at the vector for the position of this sphere, this 3 meters would be represented by a vector of 30. And that is because of our internal unit. If we were to set the internal unit to 1, then the value would stay the same, but the size of our object would be slightly larger, and the position would actually be 30 meters. So we would end up with a vector of 30 representing 30 meters rather than 3 meters. And because of this, it is important to pay attention to our internal unit, because we are going to be using the object's vector output to control those blend ratios and any other extractable slider within the function editor. So I'm going to remove this sphere from the scene, and we're going to take a look at the node we're going to be creating. So I just added in a procedural terrain to the scene, go to edit its function, and I'm going to set up that blend again with a noise node and a simple fractal, creating our combiner node with the blend and connecting. And now I'm going to load in the meta node I've created, which is an advanced range control. And this is the node we're going to be creating. If we edit our node, we can take a look at all of the different node setups. This is going to seem a little confusing at first if you're not familiar with the function editor, and we're going to be breaking this down and taking a look at how it was created and starting from scratch, and going through the development process of what each of these different sections does, because it's really not as complex as it looks. So in order for this to work, we need to have a control object in the scene. And in this case, what we're going to be using is a sphere. So now we have our sphere in the scene, and I'm going to rename this controller. And we'll go back to our procedural terrain, edit the object, edit our function. And now when we go to our controller part of this node, we have the controller sphere we just created. I'm going to connect this to the position. Now the way this is set up is it allows us to connect the blender to any of the axes we'd like to control this blend. Now what I want to do is use the Z. So we're going to be using the up and down axis to control this blend between a number of 0 and 1. There's a built-in internal unit changer, so depending on the internal unit you're using, you can change this value to match the scene's internal unit to make this node work correctly. Under Z range, we can now type in a value for the total range of our position that we'd like to control between the values of 0 and 1. So if I change this to 20, we're now going to have 20-meter range of control between the values of 0 and 1, which is set by our low number and high number. If you're working with something other than a blender that has a different low and high number, or you'd like to set these values manually, then you can change the low and high number. So if we were controlling the largest feature of a fractal, if we take a look, the value is between 0.1 and 1,000. So if we wanted to control that 20-meter range to go between 0.1 and 1,000, we would only need to change the low number to 0.1 and change the high number to 1,000. Or we could restrict it and bring it down to 300 and really set the total range. This is a pretty powerful node and allows us a lot of control over the object. We also have an offset that's going to be built in, and that I already have set up, so that if we have any sort of changes to the position or size, in this case it would be position of the vector, we could set that value so that we could manipulate the position of the initial controller without it manipulating the blend. And to show that, I'm going to type in a value of -10 on the Z. And what that's going to do is allow me to move our sphere to a position of 10, which doesn't look like it's going to be high enough to be able to see it. So let's go back and manipulate that. And we're going to set that range to -20. Now I'm using negative because I'm going to be moving the object in the positive range. So by setting a negative range, we're subtracting that initial movement that we have. So let's go back to our controller, set this to 20, and now we can see it showing up in the scene. And because our procedural terrain is not going to refresh, I'm going to open up the preview on the side, and let's take a look at our control. Now we set the value to 20 meters on the Z. So right now at 20, the blender is set to 0. If we change it to 40 meters, it's going to set the blender output to 1. So now we are seeing the noise node and not the fractal. If we set this to 30, we're going to see a value of 0.5 and halfway between the blender, between these two nodes. So it's a control for our range slider of the blender output ratio between 0 and 1, which is represented by 20 at 0 and 40 at 1, because we set our range to 20. If we set this back to 20, which is a value of 0, and now go back into our procedural function, let's go ahead and change this z range to 5. So now we have 5 meters of control. Go back to our controller, and we have 20 meters. If we change this to 25, now we have a value of 1 being represented only within that 5 meter range. We could also go a little bit over, bring it up to 30, and it's going to start to reverse the function, which is why we have the control set up, so that we can set up our range ahead of time and really know how far our objects need to be manipulated. And then in the scene itself, we could just take that, move it down, and we can see it refreshing. So this is what we're going to be taking a look at and building, because it's very powerful, and understanding how it works will really help you use it. And like I said, we could also tie this into any other extractable output. So basically, this will give you the ability to control any extractable output within the function editor of any node and any function to control procedurals of any sort. And a really nice thing about this is now we can animate it. Let's go ahead and set our z range back to 20. Go to our controller, set that initial value at 20. I'm going to hit F11 on the keyboard to bring up our timeline. I'm just going to scrub to 3 seconds. And after 3 seconds, I want to move this up to 40. And I have auto keyframing on. If you right mouse click on our little key here, you can see that. So once there's any sort of movement or change to any object in the scene at a timeline different than frame 0, it's going to automatically create our keyframe. So now we've already created an animation where we have that blender being animated by the control. And now in this case, we wouldn't want the control to show up in the scene, so we can click on its icon to hide it from view. Let's go ahead and just create a little bit of a preview. Right mouse click on this little film icon down here to open the animation preview options. I'm going to set this to preview, 10 frames a second, and the 4x size. So now it's going to generate our animation preview, and we can see that blend being animated over those 3 seconds. So there's a lot we can do with this. Now there's another part of the node, before we go and start building it, that I just want to show you. It also has a vector output. And right now we have an X range, a Y, and Z, and that's for breaking up and controlling numbers based on a specific axis. Now if we want to connect something like the origin of one of the nodes, there's also a vector output. And this is the full vector range, which means we're allowed to control. If I was to set in 20, then we would have 20 meters for the X, Y, and Z. And any position we make to the sphere is going to move the origin around. And that ties directly into the offset. And we can see that that vector is separate and doesn't have some of the control. It also doesn't use the high or low range value, because those are specific to number outputs. So to build our node, I'm just going to remove all these objects from the scene, and we are going to hide our preview. And we do want to make sure we're not building this node within the procedural terrain, and we do want to use an object graph. The reason for this is some of the outputs. I'll go ahead and load another procedural terrain so you can see this. Once I go to our output node, the only output node that is available for procedural terrain is the custom dependency. Even when working with metanodes, our output is still just a custom dependency. Well, we need the double output and vector 3 output nodes in order for this to work. We'll go ahead and remove our procedural terrain from the scene. and we're going to start building this node and taking a look at how it's going to work.